So if we look at kind of this definition or an explanation of rate of change, a rate of change compares two different quantities that are changing. So the toothpicks and the squares were a rate of change because your toothpicks were changing as your squares change. You guys have been collecting some data on your biology classes, and you're looking at how things change. I think some of you are starting butterflies projects, correct? The larva, and you're doing some monitoring. You're looking at how the growth changes, I assume some changes over time. So we're looking at two quantities that change. What happens is that slope provides us a very important visual way of looking at rate of change, all right? But sometimes we're not going to have a graph for that. We're just going to be given data. We're going to be given information, and we want to figure out what that rate of change is, okay? So let's take a look at what we have going on here. You are parachuting. At time of t equals 0 seconds, you open your parachute at a height of h equals 2,500 feet above the ground. At the time t equals 35 seconds, you are at a height of h equals 215 seconds. What is your rate of change in feet per second? Ladies and gentlemen, this last question is really important for what you're going to do because that tells you what is going to be your x and what is going to be your y. Think of how we write our slope. This is telling me feet per second from that sentence there. So that means feet is going to be my y variable, and that means seconds is going to be my x. All right? So even though they don't necessarily tell us, now here I told you in A, identify two-ordered pairs in terms of seconds and feet. They're not going to give that to you tonight. You've got to be able to read those words. So make sure you made enough notes on this example to understand how we're getting those ordered pairs. It's that feet per second, so it's feet over seconds, and so that gives me y over x. So my two-ordered pairs are going to be at 0 seconds on 2,500 feet. And at 35 seconds, I'm at 2,115 feet. So we're taking our information from that, making my two-ordered pairs, so I can find that rate of change. So now what you're going to do, you have a question? Oh, okay, okay. Now what you're going to do is actually find that. This little symbol here, ladies and gentlemen, stands for delta. And delta means change. So I think you may see that in tonight's assignment, and I think we see it again a little bit later on. When we start working on some calculator stuff, you do see this delta that just tells you how things are changing. So we want to find the change in feet over the change in seconds. That is your rate of change, obviously with all that change. So we're going to do some subtraction. I'm going to take 215 minus 2,500, and then I'm going to do 35 minus 0. So the ordered pairs line up with each other in our fraction. So this is a negative 385 over 35. Am I correct? Do we agree with those numbers? Yep. Okay, someone's double checking the math there. Thank you. What I want to try and do is divide that out, see if it simplifies it all. So let's start by simply dividing negative 385. Negative 385 divided by 35. And what do we get for that? Negative? I got negative 11. Oh, okay. So ladies and gentlemen, we have a slope of negative 11, but it needs to be labeled. And the awesome thing is there I told you what your label is going to be. Where? Feet per second. Good job. So this is negative 11 feet per second. Does that make sense? Should this have a negative slope? Jacob's shaking his head. Yeah. Why? Why not positive? You're decreasing, ladies and gentlemen. You're parachuting, correct? And what happens when you parachute? You go down. So should your slope be negative?
Yes.
Yeah. If you were climbing a mountain, if you were riding an escalator, you would have a positive slope. So you need to think about the situation to make sure that your answer makes sense there. All right? I would like you guys. Oh, my board is getting off. I want us to take a look at number 2. I'm going to have you guys do some on your own stuff here. You're typing a paper at 5:15 p.m. You have typed 275 words. By 5:27 p.m., you have typed 660 words. Find the average rate of change in words per minute. Ladies and gentlemen, is this going to be a positive slope problem or a negative slope problem? Positive, because you're increasing each of your words per minute there. All right? So I'm going to give you some time. I want you to get your ordered pairs set up. We should have 2 ordered pairs. Ethan, what did you get for your ordered pairs?
I got 515 and 275 and 527.
Good job. How many people agree? I like that. Notice each ordered pair is going to have different units in it because you're comparing 2 different things. Time to your words, time to your words. All right. It should be pretty easy to do the word calculation here because it's just 660 minus the 275. Correct, guys? All right. And so that gives me, I do want some help there, 395? 385. Thank you. I'm trying to turn things around and subtract and barrel at the same time. Time is a little bit more difficult, ladies and gentlemen. We can't type it into our calculator. All right? This one you actually could. If you typed 527 minus 515, it would give you the right number of minutes, okay? But we need to be aware that because there's not 100 minutes in an hour, there's only 60. Sometimes to calculate how much time has passed, you might actually have to count that yourself. So if we're at 527, how much time has passed since 515? 12, thank you, 12 minutes. All right, and like I said, that one was one that was easy to subtract, and you could have physically typed it into your calculator. Be careful if you change from 1 hour to the next, though. All right, guys? We're going to divide that out. What is 385 divided by 12? Ethan, did you get that divided for us? What did we get?
32.
And is there a label we can put with that? Words per minute? Or WPM. Did you guys do that in middle school with your computer classes? Measure your words per minute?
No.
I think you did, because my daughter did it last year in 6th grade, so don't you lie to me, Grant. You guys didn't have to? All right. Not in your class. Ladies and